Every time you click Login with GitHub or Sign in with Google, you're using OAuth. Today, let's see how to implement this in your own applications. I've built a GitHub Analytics dashboard that accesses your repos and displays your coding stats, all without ever touching your GitHub password. With this, we'll see how OAuth works behind the scenes. In next few minutes, we'll explore the OAuth implementation code. You'll understand the complete flow, the security considerations, and have code you can adapt for Google, Twitter, or any OAuth provider. Let's get started. Let's explore our project structure. Let's look at what each piece does. One important file to highlight here is the git ignore. Let me show you why it's essential for security. This ensures our secrets never make it to version control. Now let's look at our dependencies. We're using 4 key packages: Express for our server, Express Session for secure session management, which is crucial for OAuth security, .env for environment variables, and Axios for cleaner API calls to GitHub. Here's what environment variables you'll need. Notice I'm showing the example file, not the actual .env with real secrets. Let me show you where these values come from. Now let's register our app with GitHub. Navigate to Settings, then Developer Settings, then OAuth Apps. Click New OAuth App. These settings are important, so let's go through each one. Application name, My Analytics Dashboard. This is what users will see. Homepage URL, where our app runs locally. Callback URL. This is crucial. It's where GitHub sends users after they authenticate. It has to match exactly with what's registered in GitHub. Even a trailing slash will cause the OAuth flow to fail. GitHub provides 2 credentials. The client ID is public, like a username. The client secret is, well, secret. Never expose this in client-side code or commits. Let's explore our Express server. I'll walk you through the architecture, then we'll trace the complete OAuth flow. First thing we do is verify our OAuth credentials loaded correctly. This catches configuration issues early and prevents debugging headaches later. Now let's look at the session configuration. This session configuration is critical for OAuth security. The httpOnly flag means client-side JavaScript can't access our session cookies. This prevents XSS attacks. The same site setting provides CSRF protection. And notice, we're storing tokens in these server-side sessions, never sending them to the browser. Here's our route architecture. Login route starts the OAuth flow, callback handles the return from GitHub, and our API routes use the stored token. Let me trace through exactly what happens when a user logs in. Let's go through OAuth login and see what happens at each step. When a user clicks Login with GitHub, they hit our login endpoint. Watch what happens here. We're building GitHub's authorization URL with our client ID and the specific permissions we need. See the scope parameter? We're only requesting read access to user data and repositories, following the principle of least privilege. And this state parameter, that's our CSRF protection. Let me show you why it matters. We generate a cryptographically secure random string, store it in the session, and send it to GitHub. When GitHub sends the user back, we'll verify it matches. This prevents attackers from tricking users into authorizing their malicious apps. The user is now on GitHub's site. Notice the URL change. They're logging into GitHub directly, not our app. GitHub shows exactly what permissions we're requesting. After they approve, GitHub redirects them back to our callback route with an authorization code. See this validation? First, we verify the state parameter matches what we sent. If an attacker tried to forge this callback, the state wouldn't match and we'd reject it. Now for the crucial part, exchanging the code for an access token. This authorization code is temporary, only valid for 10 minutes and single use. We exchange it for a long-lived access token by sending it back to GitHub with our client secret. This happens entirely server-side. The user never sees our client secret. Critical security point here. We store the token in the server-side session, never send it to the client. The browser only gets a session cookie, not the actual GitHub token. Now that we have the access token secured in our session, let me show you how we use it to fetch GitHub data. Every protected route uses this middleware to verify the user has a valid session with a token. Now look how we make authenticated API calls. The token goes in the authorization header as a bearer token. GitHub validates this token and returns the user's data. Notice this error handling. If we get a 401, the token might be expired or revoked. We immediately clear it from the session and prompt re-authentication. Our client-side JavaScript calls our API endpoints, not GitHub directly. The GitHub token never appears in the browser. Our server acts as a secure proxy. See our dashboard client code? Notice it's just fetching from our own API endpoints, API/dashboard, API/stats. The client never sees or handles OAuth tokens. All the OAuth complexity stays on the server where it's secure.
And here's the result: real GitHub data, securely fetched without exposing any credentials to the client. Here's the complete flow in our server logs, every step logged for debugging and security auditing. You now have a solid understanding of how OAuth works under the hood. This implementation includes proper security, error handling, and user experience considerations that you can build upon. If you are new to the channel, I strongly suggest you check out earlier OAuth video and authentication series, links in the description. The complete code is available for you to clone and adapt. You can swap GitHub for Google, Twitter, or any OAuth provider by just changing the URLs and scopes. The pattern remains the same. Remember the key principles: tokens stay server-side, always validate state parameters, request minimal scopes, and provide secure logout. Next, we'll add PKCE for enhanced security and implement refresh tokens for better user experience. Thanks for watching. See you in the next one.